All right, turn to page 366, and let's start off here with the number 58. All right, the directions tell us to find an equation of the tangent line to the graph of the function at the given point. So we've got y equals the sine of x to the 2x, and then they give us a point. All right, now we've got an issue here we've never really faced before. The base of this expression has a variable in it, and the exponent has a variable in it. So what we want to do, so in other words, we can't use the power rule where it was like x to the something. That won't work because in that case, the to the something was a constant. And we can't use the a to the x rule because the a isn't a constant in this case. So neither one of those things work. So let's take the natural log of both sides and use logarithmic differentiation. All that means is you start off by taking the natural log of both sides, use your logarithm rules to turn this into something that you do know how to find the derivative of. So the natural log of the sine of x to the 2x, we can use the exponent property to turn that into 2x times the natural log of the sine of x. So we've got the natural log of y on the left. And then take the derivative of both sides. On the left side, now it's got to be implicit differentiation because we don't have y equals. All right, we've got the natural log of y equals, so that's different. So on the left side, treat that as u. The derivative of the natural log of u is 1 over u times the derivative of u. So the derivative of the natural log of y is 1 over y times the derivative of y. And then on the right side, use the product rule. First function, 2x, times the derivative of the second. So how do we find the derivative of the natural log of the sine of x? The derivative of the natural log of u is 1 over u times the derivative of u. So 1 over the sine of x times the derivative of the sine of x. Follow me on the first half of the product rule? So then plus the second function, the natural log of the sine of x, times the derivative of the first. And the derivative of 2x is 2. All right. Now, when we find the derivative, we need the y prime to be all by itself. So I've got a 1 over y over there with it. So what should I do to get the y prime by itself? Multiply by y. So when I multiply the left side by y, I'm just left with y prime. And when I multiply the right side by y, I get y times, and then all the rest of the right side. Now at the same time, I'm gonna simplify a little bit. 2x times that parentheses, I can just multiply the 2x times the numerator. And then the natural log of the sine of x times 2, put the 2 in front. Now, if my goal was to get the derivative, I would want to replace y with what it equals. I would want to replace y with that and then simplify. And there'd probably be a lot of simplifying to do. But that's not really my goal, is it? My goal is to get the equation of the tangent line. Since I know a point that this tangent line goes through, I can substitute pi over 2 in for x, there, and there, and there, and there. And I can substitute 1 in for y right there. That's not so bad, now is it? So that's what I'm going to do. So at the point, pi over 2, 1, y prime equals. Then I replace y with 1 and I replace all of those x's with pi over 2. All right, so multiplying by 1, well, we can do that. And then 2 times pi over 2 gives us pi. The cosine of pi over 2 is 0. I don't really care at this point what the sine of pi over 2 is, as long as it's not 0, right? Well, it's not. It's 1. So that's where all that comes from. And then 2 times the natural log of the sine of pi over 2. Sine of pi over 2 is 1, so that's 2 times the natural log of 1. All right, well, pi times 0 is 0. 0 divided by 1 is still 0. The natural log of 1 is 0, so 2 times 0 is 0. So the derivative equals 0. Okay. I don't have to go through the problem of doing the y minus y1 equals m times x minus x1. I know what the equation of this tangent line is. Do you? What kind of a tangent line is it? What's special about this one? It's horizontal. And what's the equation of a horizontal line that goes through that point and has a y-coordinate of 1? You're making it too complicated. Y equals 1, right? I mean, you can do this if you want. But look what happens. Y minus 1 equals 0 times x minus, what did I mark out? Pi over 2. So y minus 1 equals 0. Y equals 1. But look, if you've got a y-coordinate of 1 on a horizontal line, isn't the equation of that horizontal line y equals 1? So the tangent line is horizontal, and it's y equals 1. And the only reason I wrote the tangent line is horizontal is if this was a free response question on the AP test, they probably want to see all my, well, I know they want to see all my work. So as opposed to writing out the point slope form, I'm explaining to them how I know it's the line y equals 1. Okay? Does that take care of 58? Okay. Let's give 64 a shot. All right. I don't even know where to start, do you? That doesn't look like anything I'm familiar with. So let's see. What have we learned in this section? Let's flip back. Where is it? I'm still not finding it, even though I'm looking for it. Oh, it's on page 363. They give us the integral of a to the x dx equals 1 over the natural log of a times a to the x plus c. And we've been doing this a while. Wouldn't it be just the same if I changed the x to u? Make that, that, and that. So that's what I want to use. If that's what I'm going to use, there's the A. It's the only constant in the whole thing, right? Which means that's got to be U, the whole thing, not just the 3 minus x, but the 3 minus x quantity squared has got to be the U, doesn't it? And so we've got to make that dx work out to be du. All right, so we don't really have any choices here. Either that's going to work or we can't work this one right now. So let's see. So we let u equal the exponent, 3 minus x, quantity squared. And if we do that, then we got to figure out what du equals. And we got to chain rule this. So that would be 2 times 3 minus x to the 1 times the derivative of 3 minus x, which is negative 1 dx. All right, so I'm all about this that I've underlined in blue, but the 2 times negative 1, that's just in the way, isn't it? So let's multiply both sides by negative 1/2. I think we're in business now. Let's see if we are. All right. So this can be 7 to the u, and then this can be negative 1/2 du. And it fits that form, doesn't it? Okay, so let's go ahead and make that substitution. So we've got the negative 1/2 out in front. And then the integral of a to the u du is 1 over the natural log of a. So 1 over the natural log of 7 times a to the u. So times 7 to the u. I just stuck it in the numerator. Plus c. And the only thing left to do, well, we need to multiply the negative 1/2 times that. And then we need to change the u into 3 minus x quantity squared, don't we? So let's do those two things. So that'd be negative. And then let's look at the denominator first. 2 times the natural log of 7 is just 2 times the natural log of 7. And then in the numerator, 1 u is 7 to the u, but instead of u, put 3 minus x quantity squared. And don't forget, plus c. Well, that was fun. All right, even I didn't think that was fun. It's fun now that it's over. Still not fun? All right, let's try a definite integral. So that's what we're going to try to use. Well, it looks like a ought to be the 4, which means the x over 2, or you could think of that as 1/2 x. That's what u needs to equal, isn't it? So let u equal x over 2. Now that is the same thing as 1/2 x. So to get du, what's the derivative of x over 2? 1/2. So du equals 1/2 dx. We don't have a 1/2. Multiply both sides by 2. 2 du equals dx. So we're good on that part of the substitution, aren't we? We can do that. Don't have to write this down now. In fact, don't write it down now. But we can do this, right? We can make that 4 to the u 2 du, all right? But the reason I'm telling you not to write it down yet is because we've got to change the limits of integration. So, if x equals 2, u would equal 2 over 2, which is 1. If x equals negative 2, u equals negative 2 over 2, which is negative 1. So, if we change our limits of integration, I think we're good now, aren't we? So, we make our substitution. So we get 2 times the integral from negative 1 to 1 of 4 to the u du. All right, so we got the 2 out in front. And what's the integral of 4 to the u du turn out to be? It's 1 over the natural log of a, so that puts the natural log of 4 in the denominator, times a to the u, so that puts 4 to the u in the numerator, and instead of plus c, evaluated from negative 1 to 1. Now, remember, at any point, we can factor out constants. The natural log of 4 is a constant. So instead of having to evaluate using the natural log of 4 in there twice, you know, for the capital F of B, and then using it again for the capital F of A, doing it twice, just factor it out and put it in front, and we'll only have to do it once. We'll just multiply by that at the end. So 2 over the natural log of 4 is our constant. And then now we're just evaluating 4 to the u from negative 1 to 1. It's not wrong if you don't do that, but you are making your work a little easier but if you factor out that constant. Okay? All right. Before I actually do the evaluation here, I can rewrite the natural log of 4 as the natural log of 2 squared, correct? And can't I rewrite that as 2 times the natural log of 2? Should I? Because then I can get rid of a 2. So change the natural log of 4 to 2 times the natural log of 2. And again, it's not wrong if you don't, but it is going to help us simplify this if we do, okay? So then we'll get 4 to the 1 minus 4 to the negative 1 inside our brackets. Those 2's divide out, so we get 1 over the natural log of 2 times 4 minus 1/4. All right, 4 minus 1/4, that'd be 16/4 minus 1/4. That's just about 15/4. Don't much care for the fraction in my numerator, so multiply by 4 over 4 and finish it that way. All right, now, sneak preview. On the AP test, if this is a free response question, you don't have to simplify it this far. If it's a multiple choice question, you probably do. That's probably the answer that you will see as a choice, okay? So it's not as if they never make you simplify things on the AP test. They do, because there's a lot more multiple choice questions than there are free response questions, all right? But on the free response portion, if you did not do that, if you just left this as 2 over the natural log of 4 times 4 minus 1/4, they're fine with it. You get full credit for that. Now, here's the thing. Here's the catch-22. Sometimes you have to use your answer from part A to do something with it on part B. Not all the time. They're actually pretty good about keeping the parts separate, so that if you mess up A, that doesn't mean you can't get B right. Okay? But if you need to use that answer in a next part, it's going to be more difficult to use than that answer is. But look at it. It's not going to be that much more difficult to use, is it? It's not like that's a piece of cake to use in something. Okay? So, on the free response, use your time wisely and don't spend a lot of time doing arithmetic. Okay? Make sense? Now, having said that, I've never known of a college professor that said don't simplify your answers. Maybe that's what they all say nowadays. I don't know. I graduated in 1985, so it's been a while. Okay? But I kind of think your college people are going to want you to simplify your answers. And if not, well then, woohoo, you get to leave off the simplifying. All right, we good on this one? Number 80. All right, here on number 80. After T years, the value of a car purchased for $20,000 is V of T, so value at time T, not velocity, value, equals 20,000 times 3/4 to the T. Part A, use a graphing utility to graph the function and determine the value of the car 2 years after it was purchased. All right, then we'll look at the others once we get that done. So, get out your calculator. And let's see. So I'm going to change the window first because I'm going to forget to if I don't. Let me do that. All right, so we're going to need our Y value to go up to 20,000. We can start with X at 0. Going to 10 is probably okay. We'll start with Y 0. We'll make that maximum 20,000. And I don't even know what to do with the Y scale and the X scale. I don't remember. Let's see if we leave it alone. Maybe that'd be okay. All right, so we go to Y equals, and we need to type in 20,000 times 3/4 to the X. Uh-oh. To the X. All right, so kind of depressing, isn't it? Because people try to trick themselves into saying that I can get a new car. It's an investment. You are the world's worst financial planner if that's your investment. Are you not? I mean, if I had $20,000 and I went to Simi and said, Simi, help me invest this money, and that's what it looks like, I would be very disappointed in Simi and myself for trusting her. Yeah, you bank on that. Okay, so we've graphed that, and then we're supposed to see what it equals, what the value is after 2 years. So let's see, second calc, value when X equals 2, so $11,250. So draw your graph, and V of 2 equals $11,250. The pain's only begun because it looks like it's going to go. I wonder what it's worth after 10 years. Is that part of the rest of the problem? No. Second account, value, 10 years. It's worth a little over 1,000. Now, I'm not saying don't buy a new car. I'm just saying don't buy one as an investment. I mean, you got to have a car. Okay? So just don't trick yourself into thinking you're making an investment. You're spending money because you need a car. That's different. You know, paying your utility bills aren't investments either. You pay them because you want heat in your house. It's not an investment. All right, part B. What's B say to do? Find the rates of change of V with respect to T when T equals 1 and T equals 4. Rates of change. We've never talked about rate of change, have we? All right, brand new concept. Derivative is the rate of change. I know, who knew? All right, so we need to take the derivative of our value function. So dv dt stands for rate of change of the value with respect to t. All right, so that's the derivative. Well, first of all, let's do constant multiple rule. So that'd be 20,000 times whatever the derivative of a to the t is. Well, the derivative of a to the u is a to the u times the natural log of a. Or natural log of a times a to the u. I think that's the way the book said it. All right, so copy down the 20,000 using the constant multiple rule. There's our a to the u. In this case, it's actually a to the x. A to the x. So it's a to the x times the natural log of a. No times the derivative of u. Or if you did the derivative of u, what's the derivative of t? 1. So, all right. And there's not much simplifying you can do to that. So let's see what it equals when t equals 1. So that'd be 20,000 times 3/4 to the 1 times the natural log of 3/4. And at that point, I'm going calculator on you. 20, 1, 2, 3, times 3/4 times the natural log of 3/4. All right, so it's losing value very quickly at the end of 1 year. You wake up one day and it's worth $4,315.23.1 less than it was the day before. Not really, but that's what the rate is at that point. All right, then do the same thing when t equals 4. 1,000 times 3/4 to the, ooh, I bet I should have put parentheses around that. I'm not sure. When in doubt, put a parentheses. Times natural log of 3/4. Yep. Now, if you ever wonder why old people like to keep their cars and run them till they don't run anymore, it's because, look, after 4 years, it's not losing its value near. It actually becomes not a financial burden after a while. Okay? So that's why people like to keep cars and they run them till they do not run anymore. You go buy a used one. That's what I do. I don't need a cool car. I know what you're thinking. Yes, you do. All right. C. Use a graphing utility to graph v prime of t and determine the horizontal asymptote of v prime of t. Interpret its meaning in the context of the problem. Oh my gosh, they're going to expect us to think. How dare they? Yeah. Who do they think we are? Is a better question. All right, so let's see. I want to turn that one off. Let's see. What was our derivative? It was 20,000 times 3/4. Left off parentheses again, didn't I? To the x times the natural log of 3/4. I wonder what my window needs to be now. I want to go back to standard and see what happens. Yeah. I didn't need the same window I had before. So let's see. Start at 0. I need my maximum to be 0. Because, yeah, the derivative's negative, right? Because it's always loose. It's never going to gain value again. So it's negative. So make the minimum, I don't know, negative. Is that 20,000 or is that 2,000? 20,000. Okay, I think I'm good. Am I good? Thank you. All right, so what's the horizontal asymptote? Yeah, y equals 0. All right, now this is the rate of change. So the rate of change is negative, but it's increasing. So negative means that the car's losing value, but it's increasing, so it's losing value at a slower rate, right? Because look, oops, I thought I could draw a line on that for some silly reason. The value there, it's more negative there than it is there. It's flattening out to be close to 0. So what does that mean? As the car gets older, what happens? The rate of change isn't as big. So again, it's back to the why do old people keep their cars? Because once it's only worth $1,000, it doesn't get worth a whole lot less than that. Okay? So the depreciation is less. So I wrote it this way. As the car gets older, it depreciates less and will always have some value. Even if it's just the value of its parts smushed into a little rectangle sold for scrap. Like once it becomes an antique. Ooh. Yeah. That's true. Bad investments in your future. All right, number 82. Have you ever seen this? You have to. So these should be easy problems, should they not? So, total amount equals the principal times E to the rate times time. So, on 82, we're supposed to complete the table to determine the balance A, that's the amount, for P, that's the principal, dollars, invested at rate R for T years, and compounded N times per year. So for number 82, our principal is $2,500. Our rate is 6%, which we want to convert that to a decimal, so 0.06, and T is 20 years. Okay, now, hang on. All right, if you flip back to page 364, they give us two ways or two compound interest formulas. Number one, that's the formula you use for compounded N times per year. And number two is the formula you use for compounded continuously. All right? So, let me take a picture of that. There's my camera. I don't know what that noise is. Y'all hear something? Oh, y'all didn't tell me it was Fumi. Here you go. Thank you. All right, so here on number 82, those are the two formulas we need to use. All right, so let's see if we can get this thing finished before the bell rings. If we use the compounded N times per year formula, A equals P times 1 plus R over N to the NT. That'll be A equals, all right, our principal is 2,500 times the quantity, 1 plus, all right, R is 0.06 over N to the R, or NT. T is 20, so 20N. And then A equals PE to the RT, that'll be 2,500 times E to the 0.06 times 20. And it is calculator time. Okay, so that'll be 2,500 times 1 plus 0.06 divided by x to the 20x. All right, and I can make a table First, we want to do this for x equals 1, and we'll get 8,017 point, I don't know where I got the 8.4. Can I tell that to give me more decimals? Yeah, there's probably some way somewhere. 2 times, uh-oh, I'm not getting the same thing. What did I type in wrong? 2,500. 1 plus. Not enough parentheses. That's more like it. All right, so that gets us the first part of the chart. And then the second part, we need to use our second equation. So let's go back to y equals. I'm going to turn that one off. So that'd be 2,500. Let's see. E to the 0.06 times 20. Actually, that's just going to be a constant. I don't even need to make it a function, do I? Ooh. Bad idea, bad idea. Well, see, now that I've made it an equation, I don't know what to do with it. There it is. So, if you're the investor, what's your best deal? Compounded continuously. Compounded daily, not so bad. Compounded once, go somewhere else. All right. So be sure to tell Miss McDowell we did finance stuff and calculus today. And then explain the calculus to her. All right. And I have an idea tomorrow will be a let's go over a lot of questions day, because we didn't go over Friday's stuff yet either.